Okay, here we go. This is 3.4 parallel lines and triangles. So let's start with this postulate here. It says through a point not on a line, there is one and only one line parallel to the given line. Okay, so that sounds like a lot, but basically all that's saying is that if we have a line and you have a point that's not on that line, there's only one line that can go through this point and be parallel to that line. Any other line that we would draw through that point is not going to be parallel. Okay, that's all that's saying. All right, the next thing, the triangle sum theorem. There we go. The sum of the measures of the angles of a triangle is 180 degrees. Go ahead and pause the video, jot that down. And when we're in a normal year, I usually do this activity with my students. You could do this at your desk, you could do this at home. If you draw any triangle on a piece of paper, any triangle you want, and you cut off the edges, if you just cut these off, and then if you stack them up next to each other, you're going to notice that they form a straight line. Okay, so that's kind of a fun way to kind of prove that a triangle, its interior angles add up to 180 degrees because they form a straight line. All right, so let's just take an example to try to look at one of these. So find the missing angle. Basically what we're going to be doing here, so if we're given a triangle and if we have, this is 42 degrees. This looks fairly right, but I'm going to say it's a little off. If we say that, this angle here is 42 and this angle is 95, how do I figure out this angle? Well, all we have to do is add up 42 and 95, which is 137, and take that total and subtract it from 180, and we'll be left with the remaining degree. So that is 43 degrees is equal to x. Okay? All right, moving on. We're not going to spend a whole lot of time this year on proofs, so I'm going to link a secondary video just to show you guys if you're interested in how to prove things in geometry. You can watch that video. I'm going to skip it for now because I don't want to confuse anyone, so I'm just going to move on, but if you are interested, I will link that in my Google Doc. All right, let's take a look at this example here. All right, so we need to find x. Two angles have been given to us. We have 76 degrees and 47 degrees. This angle right here, we do not know. We do know it's 6 times x minus 9. So we need to find x. So what we need to do, if we know that the interior angles of a triangle add up to 180, then all we need to do is set up an equation where 76 plus 47 plus 6x minus 9, all those angles have to add up or equal 180. Set up that equation and solve. So we're going to combine these like terms. I believe that's 114. Drop down this 6x and the equal sign equals 180. And now we just have a two-step equation. Go ahead and get the variable term by itself. So we'll subtract this 114 out. Do it to one side, you got to do it to the other side. And I'm left with 6x is equal to 66. And last step, this is 6 times x. We do the inverse operation and divide by 6 on both sides, and we're left with x is equal to 11. All right, let's take a look at the back page of your notes here. All right, I got a couple of definitions for you, so pause the video, get these jotted down. An exterior angle of a polygon is an angle formed by a side and the extension of an adjacent side. Okay, so right here, the example of that would be this angle right here, this angle 1 for all of these. This would be an exterior angle. All right, and remote interior angles are non-adjacent angles to, non-adjacent angle to an exterior angle. In a triangle, there are 2 remote interior angles for every interior angle. Okay, so that would be referring to angles 2 and 3. These would be remote interior angles to the exterior angle 1. Okay, all right, moving on here. We have the triangle exterior angle theorem, which states that the measure of each exterior angle of a triangle equals the sum of its 2 remote interior angles. Okay, so basically all that means is that 3 and 2, when you add them together, they will equal angle 1, or the exterior angle. Okay, so let's take a look at that. Let's draw a triangle here. Hopefully this makes a nice triangle for me. It didn't, but that's all right. Okay, if I have, let's see, I'm going to make one of these have a remote angle. So if I have this remote angle as 93 degrees, this angle here is 34 degrees. How do I figure out this angle here, this angle X? Well, all we have to know is that this angle and this angle have to add up to equal this exterior angle. So all we have to do is set up an equation. X plus 34 has to equal 93. And I wrote 94, sorry. And then we just go ahead and solve that equation by subtracting 34 on both sides, and we get X is equal to 59. All right. That's all we got. The rest of the time is for you to practice. I'm going to give you a few examples. Why don't you guys give them a shot? Okay, there we go. So if you guys can draw these out, pause the video, give these a shot, and then I'll go through them. All right, I'm going to start with this big one here. So where do I start with this one? I think I'm going to start with letter C, okay, because I know that this angle here and C have to form a linear pair. So if I just do 180 minus 55, I will have C. 125 degrees. All right, so I'm going to write this in here too. We got 125 degrees. All right, now I see that I have this triangle here, DCE. And so I know that the interior angles all add up to 180. So if I do D plus 125 plus 32 is equal to 180 and solve for D, I will get 23. All right. How do I figure out B? Well, this box here, right, that means 90 degrees, right? So if I do 90 minus 32, I'm going to be left with 58. There's my measure of B. And now, if I recognize that I have this smaller triangle, right, if B, here, let's write this in here. If B is 58 degrees, well, now I have this triangle here, a smaller one, so I have 55 plus 58. If I add those together and subtract them from 180, I'm going to be left with 67. There is 67. All right, and last but not least, I should recognize that this larger triangle, right, the whole thing, D, A to E, E is going to equal, right, that is the exterior angle. So if I look at the measures of D, oh, I didn't even write D in here. D was 23 degrees. If I recognize that D and A are the remote interior angles, if I add them up, that will equal E. So add up 60, 67 and 23, and we get 90 degrees, which should make sense, seeing how on this side we have 90, right? 90 degrees here. This should also be 90 degrees because they form a straight line. All right, moving on. This one should be pretty easy for us. We know that the interior angles add up to 180. So if you start with 180 and we do, how about we just put in an X here? So 74 plus 42 plus X, and solve this equation. We combine these like terms, get 116 plus X is equal to 180. Subtract 116. Do it to one side, gotta do it to the other side. And I'm left with X equals 64 degrees. All right, last problem we got for today. A little hard to see, so I'm gonna zoom way in here. All right, so we have a exterior angle and two remote angles, right? Two remote interior angles. So we know from the theorem that these two angles here will add up to equal this angle out here. So we just set up an equation. X minus 3 plus 5x plus 4 is equal to 131. And we just solve this equation. Combine like terms, combine our x's, we get 13x. Add up our constants. Negative 3 plus 4 is positive 1. It's equal to 131. And then we got a two-step equation. Subtract 1 on both sides. We're left with 13x is equal to 130. And last, we divide by 13 on both sides, and we're left with 1x is equal to 10. All right, hopefully this all made sense. If you need help, come see me. Good luck.